Hello. Yesterday and the day before, we looked at exponential functions, which basically meant we look at different things where there was a variable as an exponent. Those things included exponential growth, exponential decay, compound interest, and when we looked at the compound interest the compound interest problem, we looked at the graph and could solve it using the graph. Today we're going to talk about how we can do that without having to look at the graph. And one way we can do that is by using logarithms. A logarithm is basically a way that we are able to calculate and solve an exponential function. Okay, so looking at what we have here, we know that 2 to the 4th equals, we know that 2 squared equals 4 and 2 to the 4th equals 16. But we don't really know what our value of x would be for 2 to the x equals 6. In order to do that, we use logarithms. And right now it's not written using logarithms, it's just an exponential function, 2 to the x equals 6. What we're going to look at today is how we can rewrite those problems so that we do use logs, so we can put logarithms, so we can put them into our calculator and solve. Okay, so this has got a lot of information on it on this slide. The definition of a logarithm with base b. So it says let b and y be positive real numbers where b does not equal 1, and the logarithm of y with base b is denoted by log base b of y. And basically, much like we do with a lot of things, we can write the same problem in more than one way. So here on the left, what I'm highlighting in green, is what we would call logarithm form. Most of the time I'm just going to call it log, not logarithm. So this is log form, which basically means you've written it in terms of a log with a certain base. Okay, over here on the right, b to the x equals y, that's how you would write the exact same thing in exponent form. So logarithmic form is just an equivalent way to write an equation, like 0.5 is a half, or 3/4 is 0.75, things like that. So if you look down here on the bottom are just some examples writing the same thing two different ways. In logarithm form, log base 3 of 9 equals 2. In exponential form, it would be 3 to the 2nd power equals 9. If you notice, when it says log base 3, the base is 3 over here on the left, the base is 3 over here on the right. Okay, and also notice that what it equals, the log base 3 of 9 equals 2, that 2 is the exponent, and log base 3 of 9, if you notice, it's just a different way of writing it using the same numbers. So if you look, log base 6 of 1 equals 0 could be rewritten as 6 to the 0 power equals 1, which is a true statement. And log base 1/2 of 16 equals -4 is the same thing as saying 1/2 to the -4th power equals 16. Just different ways to write the same thing. So let's actually just practice doing that. Just rewriting, it's written in exponent form. Let's rewrite it as a log. Okay, so right now it's 5 to the 2nd power equals 25. Okay, if we were going to rewrite that, that would be the same as writing log, oops, let me pick a different color here, log, and again, it's base 5 to the 2nd power, 5 is the base, so we're going to have log base 5 of 25 equals 2. Okay, again, kind of just looking at several different examples. On letter B, 10 is our base. Okay, our exponent is -1 and it equals 0.1. If we are going to rewrite that, we would rewrite it as log base 10 of 0.1 equals -1. Okay, and moving on to letter C, just looking at the examples, just multiple examples here. We would have log, again, our base is 8, log base 8 of 4 equals 2/3. Okay, and let's go ahead and look at the next one. We would have log 6 is our base, so we're going to have base 6 of 1 over 216 equals -3. Okay. All right, so down here we have log base 4 of 64 equals x. And log base 7 of 49 equals x. One way that you can actually use this is by looking at an exponential decay problem here. Okay, so it says the value of a car in thousands of dollars can be approximated by the model y equals 25 times 0.85 to the t, where t is how many years it is since the car was new. We did this problem and we looked at a graph with it the other day, so we were just going to look at a different way that we could solve this rather than having to put it in, graph it, move our cursor up and down that graph. Okay, we could have used logarithms to solve this problem. So let's look at how we would actually write this equation. So it's telling us that y equals 8. Okay, so we would write that equation as 8 equals 25 times 0.85 to the t. This gets a little bit more into solving some equations with logs than we've talked about, but this is an example of how we could use it. Basically, this is saying that 25 means that the car was worth $25,000 when it was new. The 0.85 indicates that basically each year the car depreciates by 15%. So if we wanted to calculate what the value of t would be, if we wanted to write it as a log, the first thing we would want to do is we would want to get the exponent part all by itself on one side. Okay, so we want to isolate the exponent, which means in order to do that, we would need to divide both sides by 25. Let's go ahead and divide both sides by 25. 8 divided by 25 is 0.32. So we have 0.32 equals 0.85 to the t. Okay, so if we wanted to rewrite that in log form, we would say that log base 0.85 of 0.32, and just keeping in mind as we're writing these logs that 0.85 is a base, so it's a subscript down below, equals t. Now we can go ahead and put that into our calculator. On your graphing calculator, to find the log, you're going to want to go ahead and hit the math button, and it brings up a whole list of things. And if you arrow down past where it says 9 with the arrow down, all the way down to the letter A, it says log base. If you hit enter, it'll bring up log, and you can put in the base and you can put in the number you're finding the log of. So we are going to find the log base 0.85, and then we're going to arrow over inside the parentheses of 0.32. And if we hit enter, it tells us it's approximately, that t is approximately 7.011. So after approximately 7 years is when the car that after approximately 7 years is when the car will be worth $8,000. Okay, so now we're just going to go the other way. We are going to rewrite each equation in exponential form. So if we have log base 2 of 16 equals 4, that means that 2, that's our base, to the 4th power equals 16. Again, there's nothing to solve here. We're just rewriting the problem. We have log base 4 of 1 equals 0, means that 4 to the 0 power equals 1. Log base 12 of 12 equals 1 means 12 to the first power equals 12. Log base 1/4 of 4 equals -1 means 1/4 to the -1 power equals 4. And moving on here, that would be 3 to the x equals 9, and 5 to the x equals 125. In the example with the car and the depreciation of the car, we used our calculator to figure out logarithms. Let's just practice that a few more times. We have log base 4 of 64. So let's go into our calculator. If we hit math and arrow all the way down to log base, we have log base 4, arrow over to 60 of 64, hit enter, and we get log base 4 of 64 equals 3. You can take a minute here to figure out the rest of these and practice putting them into your calculator. Log base 5 of 0.2 is -1. Log base 1/5 of 125 is -3, and log base 36 of 6 is 1/2. Again, practice putting those into your calculator. Practice using that log base button on your calculator so that it becomes much easier. So what we have here is just a little bit of an example of the things that we've done so far today. The first problems here say rewrite the equation in exponential form. Log base 3 of 81 equals 4. If we rewrite that, that would be 3 to the 4th equals 81. If I have log base 7 of 7 equals 1, that means 7 to the 1st equals 7. Log base 14 of 1 equals 0 means 14 to the 0 power equals 1. Log base 1/2 of 32 would be 1/2 to the -5th equals 32. And again, just going back the other way, 7 to the 2nd power equals 49. If we were going to rewrite that in log form, that would mean that we would have log base 7 of 49 equals 2. Okay, just a couple more examples. If we had log base 50 of 1 equals 0. 4 to the -1 would be rewritten as log base 4 of -1 equals, excuse me there, we would have log base 4 of 1/4, oops, color here, of 1/4 equals -1. And the last one would be log base 256 of 2 equals 1/8. For putting these into our calculator, 9, 10, and 11, log base 2 of 32, again, that's the math button, arrow down to the log base button, hit enter, and you can put in your base and your number. Log base 2 of 32 is 5. Log base 27 of 3 is 2. And if there is not a base, it is assumed that the base is 10. So log base 10 of 12 is 1.08. Thanks.